In this video, we are going to talk about ANOVA, and we are also going to calculate ANOVA using Excel. So let's get started. ANOVA is analysis of variance. When do we use ANOVA? When we are comparing two or more groups and their means. Analysis of variance, there are two different designs. One is called between subject design, when different participants are assigned to different groups. And within subject design means research participants are assigned to all levels of the independent variables. So they are being tested repeatedly. In this video, we are sticking with between subject design. Okay, so there are different variance, different sources of variance. The first one we want to talk about is the total variation, sum of square total, SST. And the total sum of square basically can be partitioned into two different sources. One is from systematic differences due to study effect, and that's something we call sum of square between. That's what SSB stands for. And on the right-hand side, that's the individual differences or measurement error, and that's what we call the sum of square within. That's what SSW stands for. And here are some visualization to help you understand where does the sum of square total come from. So basically, calculating each individual value xij minus x bar bar. So each individual value's differences from the simple mean x bar bar. You calculate their differences, you do square the differences, and then you add it up. That's how you calculate sum of square total. Okay, visualizing sum of square between, so SSB. Sum of square between is actually, as you can see, this is what I call horizontal comparison. It's compare each group mean, x bar 1, x bar 2, x bar 3 is the group mean for each group. And because each group have a different number of people in it, so you have to compare the group, consider the group size. So it's N1, N2, N3 is how many people in each group. So the calculation here is x bar j, which means which group mean you are comparing to. Each group mean right here minus the x bar bar, the total sample mean. And again, you do a square of the differences. And before you add it up, you have to times the group size. The nj is the group size for each group. The next, visualizing the sum of square within the XSW. Sum of square within reflects the variability within group, which reference to the individual differences or a simpler measurement error within each group. And this is a horizontal comparison, so it's individual value within the group compared to its own group mean. So you do this with group 1, and you see the blue curved line is the operation you need to do. Individual value minus the corresponding group mean, you calculate the differences and do a square of the difference. Square total equal to sum of square between plus sum of square within. And to know all that is to prepare you to put all the number into a ANOVA summary table. So basically, we have source of the variances. So the source come from between groups, come from within group, and come from total. And then we need to calculate the sum of square. So we have sum of square between SSB, sum of square within SSW, and sum of square total. And for each one of these, you need to have degree of freedom. The degree of freedom for the sum of square between is k minus 1. K is number of groups you have. So in the example, we have 3 groups, and the degree of freedom for between is going to be 3 minus 1, so it's 2. Within group, the degree of freedom for the within group, it's n minus k, where n is the sample size, k is again number of groups. And the degree of freedom for sum of square total is going to be m minus 1. MS is mean square. Mean square in ANOVA summary table is actually the same as variance. Mean square is calculated as sum of square divided by degree of freedom. So as you can see here, sum of square divided by degree of freedom, k minus 1. That's how you calculate mean square. And this is the same for between groups and also the same for within groups. So MSW is some SSW divided by degree of freedom, n minus k. And the F test, the F ratio here is simply MS between, MSB, divided by MSW. So that's all the number go into ANOVA summary table. Now let's look at Excel, how we calculate ANOVA summary table using Excel. So assume that a food manufacturing company conducts 3 focus groups to test different advertising strategy on consumers' perception of food quality. 3 advertising strategies are tested in this study. The first group is weight control. Second group is all natural ingredients. And the third group is organic and environmental friendliness. And the participants are randomly selected from a large panel and offered compensation for their time. All participants are provided exactly the same foods, and food quality rating are assumed to be influenced by the different advertising strategies. There are 8 participants in each focus group. And here are the rating of the food quality. And let's take a look. Out of these numbers, we can go ahead and calculate group mean. So using Excel, it's very simple. Here is the cell I want to put the answer for my group mean for the first group. So I just say average, and here are the numbers. Highlight the number. So average A2, column A, row 2, all the way to column A, row 9. That's what it means. So these are the A number I want to calculate average. So the average is 6. As we talked about before, Excel has this wonderful quality. You can copy and paste if you are doing the same kind of operation. And I need to calculate mean for group 2, all natural ingredients group, and group 3, organic and environmental friendliness group. So I need to do average for these A number and the A number in group 3. So since it's the same operation, put your cursor to the lower right hand side until the solid plus appear. Hold down to the left shift key and drag it and let go. So that's the mean for group 2 is 7. the mean for group 3 is 7.75. And we will need to calculate the overall sample mean for everybody across 3 different groups. And since these 3 groups have equal group size, the average for the overall group is just going to be the average across the 3 group mean. So here, 6.91667 would be the overall sample mean. Okay, so first of all, when we calculate the sum of square total, would be all these 24 individual values, their differences compare their differences to the overall sample mean, which is this number 6.91667. So I'm going to put the calculation over here parallel to the original number. Okay, so put your cursor over the cell where you want to do the calculation. Equal sign, you tell Excel you're gonna do operation where you grab the first value, A2, and in this table, minus the sample mean, D11. That's where the location for the sample mean is, column D, row 11. And because in the process of calculating the differences square, the differences square is shift 6 key to give you the power sign in Excel. Power 2 is square. And we need to fix this value for the overall sample mean. It's going to be the same across the next 24 number operation. So you give $, which means you fix the row 11, and also you want to fix the you give it a $sign on the column. So the effect of that is it is gonna fix this value for the other calculation you're gonna do pretty soon. So hit enter. And again, the wonderful Excel characteristics, once you program the first operation, you can grab shift, hold down the shift key and the left key, and then drag it along to the last number. And this is the group 1. And right now, it's very easy. Drag it over to group 2. Drag it over to group 3. Okay. So this is basically all the individual number, its differences with the overall sample mean. Okay. So when we sum up this 24 individual calculation here, it's gonna be sum of square total. And as I put the ANOVA summary table at the bottom here, we have source of the variance between group, within group, and total. And here are the number you need to put sum of square. And right here is your individual value comparison with the overall sample mean. So that will give you the sum of square total, and the answer would be right here. So let's do sum of these 24 numbers. Okay, so sum E2 all the way to G9 is the 24 number you want to add about. Okay, so that's 47.833. Okay, and then the sum of square between is gonna be the differences of the individual group mean group 1's mean minus the overall sample mean, and again fix that value. And you need to do square the difference, and because this is the group mean compared to the overall sample mean, you need to times the number of people in the group. So we have 8 people in the group. A times the differences of group 1's mean with the overall sample mean. Okay, so you did that for the first group, and you need to continue on to do this for the second group. 8 people in the second group, the differences between the mean of second group minus the overall sample mean squared it, and do the same thing for the third group. 8 people in the third group, and group 3 mean is 7.75 minus the overall sample mean, and square the differences. Oh, sorry. Square the differences. Okay. So that's how you calculate sum of square between. Hit enter. So 12.333. And as we talked about before, sum of square within is going to be sum of square total. We calculate it as sum of square total minus sum of square between. Hit enter, and you see the differences here is 35.5. And remember, we talked about degree of freedom. For sum of square between, the degree of freedom is k minus 1, and we have 3 group, so the degree of freedom is 3 minus 1, 2. Sum of square within the degree of freedom is n minus k. N is 24, and k is 3, so 24 minus 3 is 21. Sum of square total, the degree of freedom associated with that is going to be n minus 1. 24 minus 1 is 23. Okay. Mean square is simply sum of square divided by degree of freedom. So mean square between is 6.1667, and mean square within is going to be sum of square within divided by degree of freedom within, and that would be 1.69048. And the F ratio is simply mean square between divided by mean square within. And the calculated F value in this ANOVA summary table is 3.6789. Okay, so if you don't want to calculate sum of square within by doing simple subtraction, sum of square total minus sum of square between, you can actually do the vertical comparison. And the vertical comparison is, let me shrink this screen a little bit so you can see everything. So the vertical comparison is gonna be each individual value, start from the row 2 here, individual value compared to the group mean. So the calculation is going to be individual value minus the group mean right here, and we only need to fix the row, we don't need to fix the column, because when we calculate the next group, it's going to compare to its own group mean right here. So it will be a different column. So just put a $ in the row, and you don't have to fix the $ in the column. Okay, so parentheses, remember we calculate square differences. Okay, so power 2. Alright, so that's the first one, and remember we have 8 value, so drag 1, 2, 3, 4, 5, 6, 7, 8. Alright, so when we copy the whole row there, these will be the individual value in group 2 compared to its mean 7. So let's take a look. Check. When you put your cursor on the number 4, which is the first value of group 2, the within sum of square within number, clearly you see the formula bar here is B2 minus B $11 square. B2 is right here, your first value. B $11 is right here. That's the mean for the second group. So this is a correct operation. Okay, and doing the same thing over to group 3. As you can see, it copied correctly because it's C2 minus C $11, so it's minus its own group mean right here. Okay, so let's do a summation at the end, and this sum of these 24 number is gonna give you sum of square within. So when we hit enter, just to verify the answer, it should be the same as 35.5 right here. 35.5. Voila. That's how you do ANOVA using Excel. Hope this helped with your study.